Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video as we look at segment lengths and midpoints. Now, our goal here is to make sure that we know how to name segments, just what it looks like when they talk about the segment, and even better yet, the length of a segment. That'll be very quick and dirty. And then we're going to look at something called the distance formula and something called the midpoint formula, and I'll have two examples for each of those. So let's get right down to it, guys. This is just like kind of a splash screen of sorts of good geometry information. I'm going to mostly just focus on this one right here, a line segment. However, I'm going to refer to some of the other ones in the future and just make mention of the fact that a line segment is just a portion of a line. Now, a line goes on forever in two directions, even through any points that are on it. A line, again, has infinite length. A segment does not have infinite length. It has finite length. It has two endpoints, such as these endpoints here, C and D. And you know what finite length means? It means we can measure it. Not necessarily with like a ruler or something, but we can actually get a value assigned to it. And that's what we're going to try and do. Now, as far as naming this thing goes, guys, this could be called segment CD or segment DC. It doesn't matter which order we do the letters because these don't have to go left and right. They could go up and down, whatever, it doesn't matter. Segment CD or DC, what you'll more often see is something like CD with this little bar above it or DC with this little bar above it. And you can see that this bar doesn't have any arrows on it, unlike, say, a line bar does with arrows to indicate they go on forever. This is how we name a line, but this is just how we name a segment. Now, when I'm trying to find, say, the length of segment CD, the length of CD, you might see this right here, or you might see just CD, no bar whatsoever. That is a proper notation. If I say find CD, that means find the length of it. Anyway, that's just a basic naming featurette right there. I don't know if I'm going to be using a lot of letters in all of my things, but just in case, I want to make sure that you know that in case you do any problems on your own. Okay, so that's talking about how we name segments, just what it looks like when we see them, or if we have to name them ourselves. Now let's talk about the distance formula. And this is one where I kind of come at pause here because, you know, if you see a textbook or an online thing, whatever, they're going to give you a formula, and I'm going to give you the same formula, and I'm going to do an example with you on it, but it is not my conventional way of wanting to do it, and you're going to hear me argue another way to talk about it, and I'll introduce how it was made, and I'm going to use that introduction for me to say, that's how I want to preach on about it. Okay, whenever you're trying to find the lengths between 2 points, if they were directly horizontal or vertical of one another, you could actually count out that distance. You can calculate it just through a simple subtraction. What's the distance between 5 and 3? You do 5 minus 3. You know, you can do something like that. But if there are 2 points that are diagonally across from each other like this, by the way, I'm kind of saying all of it right here. But for 2 points that are diagonally across, I can't count and go like 1, 2, 3, 4. It doesn't work that way. And there's another way to do that, not just on a graph, but I'm just in general, diagonal lengths. You can use something that's called the Pythagorean Theorem. And the idea is if you have a right triangle, you might have heard of this thing. If you have a right triangle, then the two sides that make the right angle are called legs, like say these lengths A and B, and the side opposite the right angle is called a hypotenuse C. You can find the length of C by doing a squared plus b squared and setting it equal to c squared. That's what the Pythagorean theorem is. I'm not going to spend time proving it, but you're going to hear me say Pythagorean theorem a lot. You're going to hear a squared plus b squared equals c squared a lot from me, just in general, not just in this video. And that's something to make sense of. Now, if I want to find the distance between 2 points on a graph that are diagonally across from each other, what I can do is I can use that Pythagorean theorem because I can build a right triangle. I can build a right triangle and find the distance between my y values, this vertical distance, and the distance between my x values, this horizontal distance, and use that a squared plus b squared equals c squared in the same way. And that's where the distance formula comes from. The horizontal length, A and B are the horizontal and vertical lengths, but the horizontal length is taking the distance between, say, some point x1 and some point x2 right here by doing x2 minus x1. And if I do y2 minus y1, then I find the distance between my y's. And if you're having too much confusion with that whole idea of subtracting of find distances, just think of the idea again, the distance between 5 minus 3 is 2, all that good jazz. And I know this looks a little cumbersome with all these letters and without examples. Trust me, I'll do examples after, but you need one of these two formulas to work. Anyway, so x2 minus x1, y2 minus y1 are the distances between your x's and your y's. So if you see that a is kind of this horizontal distance here, treat a kind of like a x2 minus x1, if you will, for Pythagorean theorem's sake. And then b is kind of like the distance between the y's, which is a y2 minus y1. And c is kind of like this d right here. We don't know that actual distance d yet. We're going to try and find it out. And if you look at the Pythagorean theorem, a squared plus b squared equals c squared, let's rewrite it so it says c squared equals a squared plus b squared. Same thing, I just swapped it. Let's take the square root of both sides right here. If you don't really know too much about square root stuff right now, that's okay, but you do have to know that to get c by itself, I gotta take the square root here. So the square root of c squared is c, and then you have the square root of a squared plus b squared. I can't simplify that, by the way. I can't just turn that into a plus b. I gotta leave it like this. But now if I substitute x2 minus x1 for a, I'm gonna get the square root of x2 minus x1 squared. If I substitute y2 minus y1 for b, I'm going to get y2 minus y1 squared. So this is going to be a squared plus b squared. And I'm taking that square root, and c gets substituted with d. You guys, this is the distance formula right here. And it's kind of big. And I understand that, I would allow you to use this at any time. Like, you don't have to memorize it, so to speak, but you got to know how to use it. Otherwise, I wouldn't say to use it. There are other ways that you can find out the lengths between the horizontal and vertical things and just use Pythagorean theorem. It's all Pythagorean theorem, and there are a lot of misuses to this, so just be careful. Now, you've seen y2 minus y1 and x2 minus x1 before in slope, and I'm going to do something with slope later here, so it might be helpful for you in a when in doubt, draw it out kind of scenario if you have a visual to maybe do some of the counting and just work on it that way. You'll kind of see what I mean when we go in. Anyway, we can use this distance formula here. I'm going to make sure to rewrite it on this next screen as we do an example or two. Now, the one example I'm going to do here visually, I'm just going to use a counting measure, and the next one I'll do distance formula. Find the distance between the 2 points on the graph, example number 1 here. Now, by scale, apparently it looks like this point is 2, 3, and then it looks like this point is maybe 5, 7. Let's find the distance between the 2 points here, which is basically the length of this segment. I know I haven't really been talking about segments. I just wanted to bring that up again. So in order to find this thing here, guys, if I were to think more Pythagorean theorem on this one, let's go ahead and find this vertical length right here and this horizontal length right here. If you could tell, I really just made a right triangle. What's the distance here between this x value of 2 and this y value of 5? Well, that's where you would do that 5 minus 2, but it's 1, 2, 3. So that length is 3 here. And what's the vertical distance between this y value of 3 and this y value of 7? 1, 2, 3, 4. Right, that's 7 minus 3. And I got to find this unknown. I'm going to call it c. I know it's d in the formula, but this is Pythagorean theorem to me this time. The Pythagorean theorem says a squared plus b squared equals c squared. So I'm going to go ahead and write that one out. Well, yeah, I'll start with a squared plus b squared equals c squared. So my a in this case is 3, my b in this case is 4, and then my c is what I'm trying to figure out here. 3 squared is 9, that's 3 times 3. 4 squared is 16, and then 9 plus 16 is 25. So c squared equals 25, but I have to solve for c, so I'm going to go ahead and take the square root of both sides. And the square root asks what number times itself gives you 25. That answer is going to be 5. So my distance between these two lengths here is 5. And again, that's not something I could have just counted diagonally like I could have horizontally and vertically. So when in doubt, draw it out scenario kind of worked here, but then again, this one was already drawn out. That right triangle allows me to count and do things pretty easily, or subtract if I wanted to. All right, let's do the next one. Find the distance between the points 6, -2, and 3, 7. This time I'm going to go ahead and use distance formula with you guys. I'll give you a when in doubt, draw it out scenario and show you what it looks like, but I won't continue after that. So the distance formula says x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and take the square root of the whole thing. Again, it can get a little perplexing, so just be careful here. What's this x2, x1 stuff? Well, if I have a point here that's some x1, y1, and another point that's some x2, y2, I can substitute these into here. And again, you don't want to mess anything up. What parts are the minus, what parts are the plus and stuff? It can get a little complex. That's why personally, like I said, I'm a Pythagorean Theorem guy. So square root of. So x2 is 3 minus x1 is 6. And I'm going to go ahead and square that. And then y2 here is 7. And then minus, I'm going to subtract negative 2. Remember, subtracting a negative isn't just subtraction. It actually becomes addition here. So 3 minus 6, I get negative 3, and I'm going to square that. 7 minus negative 2 becomes 7 plus 2, and that's 9. So I'm going to square 9 there. And then that becomes square root of negative 3 quantity squared is 9, and 9 squared is 81, and the square root of 9 plus 81 is the square root of 90. And for the sake of time, what we're going to do right now, guys, I'm going to leave this answer like this for now. Just, it is not, 90 is not a perfect square. And there's something called simplifying radicals that I'm sure we'll get to later, where you'll get an answer of 3 root 10. You can leave this be right now as square root of 90, though. If you approximate it, it's probably around 9.5. I don't know, something like that. But I'm not going to approximate. I'm not using the calculator right now. We'll leave it be. That's good. Now, if I did use the kind of Pythagorean theorem version of this instead of the distance formula, what I would probably do is just give this a super rough drawing. Here's 3, 7, and here's 6, negative 2. And what you're kind of just doing, once again, is building yourself a right triangle here and trying to find out, hey, what's the distance between my y's and the distance between my x's? What's the distance between 3 and 6? Those are my x's. That's 3. Between 7 and negative 2, some people have trouble with that one. The answer is not 5, because you got to go down 7 to get to 0, and then go down another 2 to get to negative 2. 7 plus 2 is 9. So you can use Pythagorean theorem again, 9 squared plus 3 squared equals c squared, and go to work there if you want. But I'll leave that up to you and make your decision. Okay, that's the distance formula in a nutshell. You can see how fast I need to make this thing go if you want it to go fast. Okay, so I'm going to mosey on over to midpoint now. Now there's some verbiage here which is really important for you to read perhaps, but also just hear my voice and look at this underlined word average. This is the key to the entire thing. The midpoint is simply finding the average of your x values and your y values, and it can look complex like the distance formula, but if you just know Pythagorean theorem, distance formula is pretty easy, and if you just know averages, midpoint's pretty easy. How do you average two numbers? You add them up and you divide by 2. If you don't know what a midpoint is, say this midpoint here I'm going to call M, the midpoint is just that half the distance between your endpoints of a segment. And remember, segment has endpoints to them. So where is the midpoint? What's its actual coordinate pair? So there are two different ways you can do this. One is kind of through the formula through averages, which involves, say, if I average my two y values, I settle right in between them at some point D for y, so averaging the y's, which is basically taking your y values and dividing them by 2, or adding them and dividing by 2. And then you can average your two x values, and you end up right at the middle of the x's, and you get this point E, the coordinate pair at least, by averaging the x's, x1 plus x2. And divide that by 2 right there. And that's what the midpoint basically is. You just average those two things. x1 plus x2 divided by 2 becomes the x coordinate of your midpoint, and y1 plus y2 divided by 2 becomes the y coordinate of your midpoint. You know, another way that you can do this, and it's really nice because you can kill two birds with one stone if you do the Pythagorean theorem thing, is if you notice there is a right triangle here. And if only I knew the distance between these two things right here and the distance between these two things right here, where is the midpoint but halfway going down that trek? What if I just go halfway, half that distance, and half that distance there, then I would land on the midpoint. And the good thing about that, like I said, is you now have these lengths and you can use those for Pythagorean theorem if you had to find the distance as well. So I'm going to do both of these. I have two more examples for you. One as a graph and one is not a graph, and then I'll use the formula. So let's take a look at these last two examples here. Find the midpoint of RS. Ooh, that should be a segment. Of segment RS right here. Now you do have to kind of know what these places are. This looks like negative 2, 7, and this looks like 6, negative 3 right here. And I got to find out its midpoint. And so I'm going to use the graph as an advantage, or to my advantage right here, and just say, how far do I go down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how far down I go in this direction to meet me to S. And how far do I go over from negative 2 to 6? That looks like 8. 1, 2, 3, 4, 5, 6, 7, 8. So over 8 like that. Let's just go half those distances. Instead of going down 10, let's go down 5. 1, 2, 3, 4, 5. And instead of going down right 8, let's go right 4. 1, 2, 3, 4. And voila, I land on my midpoint right there. And that midpoint looks like it's at the point 2, comma 2. If you're not sure, you can also do 7 minus 5 is 2, and negative 2 plus 4 is 2. And that's where we end up. That's our midpoint. And like I said, what's good about this is I now have this 10 and this 8 in Pythagorean Theorem if I really wanted to find the length of this segment RS as well, which I don't need to, but I could. And the last one I want to do is use that midpoint formula, which is, again, average the x's and average the y's and just write out the coordinate pair without drawing anything out, but of course you could. Remember, I'm kind of a fan of the drawing things whenever I can do it. The midpoint of segment AB has endpoints negative 3, negative 5, and 7, 7. So find, oh, this shouldn't say the midpoint of AB. This should just say segment AB has endpoints. Sorry, it's me kind of doing it pretty fast here. So AB has these two endpoints. Find its midpoint. So let's go ahead and average out my x's. Negative 3 can be my x1, and 7 can be my x2. So I'll do negative 3 plus 7, divide that by 2. When I average them, I do find the midpoint for x. And also negative 5 and 7 for y1 and y2. Negative 5 plus 7 divided by 2 right there. And that'll give me negative 3 plus 7 is 4. And I'm going to divide that by 2. Negative 5 plus 7, help me, is 2. And divide that one by 2. 4 divided by 2 is 2. And 2 divided by 2 is 1. And I get a midpoint of 2, 1. And that's it. That's it. That's all. So that ought to do it from me, guys. Now we've covered all three of these things: naming, segment, distance formula, and midpoint formula. And if you have any questions, go ahead and ask away. Thank you. Take care.